Hi guys, let us look at one another example on evaluating the trig functions for different angles. So in this case, we want to figure out, again guys, keep in mind we are avoiding the use of calculator right now, okay? We want to find the sine, cosine and tangent for 225 and then negative 780. So guys, let us start evaluating this. For this guys, we have to kind of go back and review the section of special angles, which include 45 45 90 angle triangle and also the 30 60 90 triangle. So guys, I'm expecting that you review that or you already know some of the basic things about it. If not, then guys, I'm quickly going to kind of recall or review that for you, but then you should also go back and review it if you are not very confident with that. So guys, again, as we have been doing for other angles or other trig functions, we have to first start by actually plotting this angle. So let us go ahead and plot this angle. So 225 guys, we know is going to be in the third quadrant because this is x, this is y, up to here is 180, and then we have to go past 180 to get to the third quadrant. So in the third quadrant, so it's going to be somewhere right here. So guys, what we do here is this whole angle basically is going to be my 225 degrees. So to make life a little easier for us and for the calculation purposes, what we do here is, guys, what we create is called the reference triangle. So reference triangle is a triangle that can be created in any quadrant, but it is always with respect to the x-axis. So if this is my angle right here, or this is my terminal side, then to create a reference triangle, guys, I have to drop a perpendicular not to this vertical side, but to the horizontal x-axis. It is always with respect to the x-axis. So this is going to be my reference triangle and it is in the third quadrant, okay? So based on this reference triangle, guys, we can do our calculations to finding the sine, cosine and the tangent. So the first step after we get the reference triangle, what we're going to try and do is we're going to try to figure out this value of this angle. So guys, if this whole angle is 225 and from here to here is 180, then you have to take 225, you have to do 225 minus 180, which gives me 45 degrees. So this is a 45 degree angle. Guys, keep in mind this is still a positive, so that's why I'm measuring in a counterclockwise direction. So guys, now we just have to focus on this reference triangle, and this is my reference angle. So basically finding the sine, cosine or tangent for this angle 225 is going to be same as finding the cosine, sine and tangent for 45 degree angle, but in this third quadrant. So now we only have to focus on this triangle. So guys, that is the first step. That is the first step for all of these types. You have to create a reference triangle, and it depends on where the terminal side is. In this case, the terminal side is in the third quadrant, so reference triangle is in the third quadrant. And we could quickly or easily figure out this reference angle, which in this case is 45. Now, for 45, we know if this is 45, this is 90, then this is also 45. So what we are talking about is a 45, 45, 90 triangle. And we know those are special triangles. That is one of the special triangles. So what is unique about a 45, 45, 90? Guys, we know how the ratios of the sides are, or we kind of know what the sides could be. So you can choose any values you like, but the ratios should satisfy that unique condition. But guys, if you remember, or if you go back and look at your textbooks, or even if you watch my previous videos on this, you will see that what we choose for this as an easy ratio to work with is that the sides are in the ratio 1 and 1, and then obviously the radius or this hypotenuse, if you like to think in terms of the hypotenuse, is going to be square root of 2. And we can easily, if you don't remember it, we can easily figure this out using the Pythagorean theorem. But guys, here's the important thing here. Now, since it is in the third quadrant, this is x is not still 1, it is going to be negative 1 because it is in the negative side. Same thing for the y, it is not going to be positive 1, it's going to be negative 1. So if I have to think in terms of x and y coordinate, the x coordinate is negative 1 and y is negative 1 as well, but the radius or the hypotenuse is going to be still positive square root of 2. So I have x, y and r. Once I have x, y and r, then it's very easy for us to write any trig function because we know the basic definition. So let us start by writing the sine. So sine of 225, which is basically same as sine of 45 in the third quadrant, right? Not in general, guys, but this particular third quadrant. Okay, keep that in mind. And that would be y over r. What is my y? Y is negative 1, r is radical 2. But we cannot leave the radical 2 in the denominator. We got to do the rationalizing. So guys, I'm going to rationalize by multiplying by radical 2 upstairs and downstairs, so I get negative radical 2 over 2. And the other thing, we know that the sine is going to be negative in the third quadrant, so it is negative in the third quadrant. Then the other one is the cosine of 225. Same thing, cosine is basically cosine of 45 in the third quadrant, not in general, but for this particular example. And cosine is what? X over r. So x is also negative 1, r is radical 2. Guys, it's basically the same thing. So times radical 2 over 2, and you get negative radical 2 over 2, which was the same as what we got for sine. Okay, but we have to do the work. We have to see what we get. And then, guys, we have the tangent. So tangent, we know, is the ratio of y over x. Y is -1, x is -1. When you divide them, you get a +1. And guys, we know that the tangent is supposed to be positive in the third quadrant, and we have a +1 here. So guys, once we have sine, cosine, and tangent, although that's all we need to figure out in this example, but if it asks us to find the cosecant or secant or cotangent, we know we just have to reciprocate things, okay? So guys, that is how we do part A. So let us now look at part B, which is going to be very similar to this. The first thing we have to do for part B, again, is we got to draw that xy coordinate plane. Once we have the xy coordinate plane, then we can start by actually drawing or identifying the angle. So -780, we know it's a negative angle, so we got to start measuring in a clockwise direction. So guys, we start from here. We always measure angles with respect to this as a fixed side or as a reference side. So if I go around once, I'm going to go 360 or -360, but it is 780, so I have to go maybe one more time. So if I go twice around, then 360 and 360 will add up to negative, or -360 and -360, because we're going clockwise, will add up to -720. But we want to get to 780, so that means I have to go 60 more to get to 780. So basically I'm going -360 once, then again -360 will add up to -720. Then I have to go 60 more in the clockwise direction to get to 780. So basically this is what we are talking about. So 780 or -780 is coterminal with -60 degrees. So I don't have to now worry about -780. All we have to focus on is the -60 terminal angle, or you can think of that as a reference angle. So guys, once I have identified, or I have this reference side reference angle -60, then we are basically going to do the same thing that we did here. We are going to create a reference triangle, and keep in mind, reference triangle is, it can be in any quadrant, but it has to be always with respect to the x-axis. So from here we are going to, anywhere from here, we're going to drop a perpendicular onto the x-axis, so we get a reference triangle. Now we just have to focus on this reference triangle. Guys, this is -60, then obviously this is going to be, depending on what we angle, this is a 60, 30, 90 triangle. And again, we know that's a special triangle, and we're supposed to know the ratios of the sides. So guys, I'm going to remind you, so 60, opposite to 60 we have radical 3, and opposite to 30 we have +1, and then my hypotenuse or radius is going to be +2. But keep in mind, it has to be consistent with the signs have to be consistent, because now we are looking at this as an x value. Guys, this is in the positive x side, so +1 is fine. +1 is fine, but this radical 3, which is the corresponding y value, but it is below x-axis, so it is not supposed to be positive, it's supposed to be negative radical 3. So guys, we got to make those changes right away. Once we see that it is in the fourth quadrant, what is positive and what is negative. We got that right. We got the values for x, we got the value for y, we got the value for r. Let us go ahead and write the sine, cosine, and tangent. So sine of -780 basically is same as sine of -60, which is y over r. For this particular reference triangle, what is my y? Y is negative radical 3 and r is +2, so that would be the sine. Now let us write the cosine. So guys, the cosine we know is x over r. X over r, what is my x? X is 1, r is 2, so 1/2 for that. And then guys, I have the last one, which is the tangent. So tangent of -780 is going to be, according to the definition, is y over x. What is my y? Y is negative radical 3, and my x is just +1, so it is just basically negative radical 3. So guys, that is how we figure out the trig values or trig functions for a given angle. So in my previous video or previous example, we did some special cases where the angles lie on the x-axis or the y-axis. Guys, in this case, they don't necessarily lie on the x or y-axis, but